Alright, in today's session we're going to be discussing polynomial operations, in particular addition and subtraction. Okay, so polynomial operations, addition and subtraction. And we're going to start off with addition. Alright, so let's get to some examples. Let's say we have 4x to the third minus 6x squared plus 2x plus 7, and that's plus 5x squared minus 2x. Alright, so we have a 4-term polynomial plus a 2-term polynomial. In this case we would call it a binomial. Alright, according to order operations, PEMDAS, we typically want to look at what's inside of parentheses and see if there's anything inside of the parentheses that can be done first. Alright, so when we look inside of this set of parentheses here, we see that none of the terms are considered like because they don't have the same variable exponent combination, so they're not like terms. So based on what's being asked, which in this case is subtraction and addition signs in here, we cannot combine any of these terms because they're not alike. Look at the other set of parentheses, the second set of parentheses, and the same case holds true. The terms inside of the parentheses are not alike, so they cannot be combined. Alright, now with polynomial addition, basically, typically you're not going to see that the terms inside of the parentheses can be combined. Alright, now I'm not saying it'll never happen, but typically the terms inside of the parentheses will be unlike. Okay, they will not be like terms. So what you're looking to do then is basically combine like terms from one set of parentheses with like terms from another set of parentheses. Alright, now the best way I can tell you to do it is to always look at all of the terms, in each set of parentheses that's presented and find the highest degree that's presented. Okay, so when I look at my first set of parentheses and my second set of parentheses, I see the highest degree for them all is the third degree. That's the highest degree for them all. So what I typically would want to do is establish x to the third now as my initial column. So anything that's x to the third I would put in this column, and that's in any of the parentheses I see. I'd line it up in this column. Okay, and then because it's customary to write your answers in standard form or decreasing or descending order, if I'm going to start with x to the third as my highest degree, then basically all I'm going to do is do a countdown from there. So I have x to the third, so I will follow that up with x to the second, follow that up with x to the first, which is just x, and then I'd follow that up with x to the 0, which is just constants. Alright, so again, this right here is just plain old x. This right here, these are my constants. That's what it means by x to the 0. Alright, they're just constants. So we're starting off with our x to the third. I see I have a 4x to the third here, so I write down my 4 for my x to the third, and I scan over all the other terms in all of the parentheses, all of the other terms in all of the parentheses, to see if there are any other x to the thirds. I don't see any. Alright, so now I can move to the next, which is my x squared. So I'm going to look for x squareds, any term that has an x squared attached to it, and it doesn't matter what set of parentheses. I'm looking at all the parentheses for x squares. So now I notice I have a negative 6x squared, so I write my negative 6, and I notice over here I have a 5x squared, so I write my positive 5. Okay, there aren't any other x squares in any of the parentheses present, so now I move to next in line, which is my x to the first, which I said is just x. X to the first is just x. So I see I have an x here, 2x, and I have an x here, which is a minus 2x. Alright, and then now I'm left with my x to the 0, which is nothing more than a constant. So I'm going to look for all my constant terms. Alright, constants mean does not have an x or a variable attached to it, and that's why we say x to the 0, because there is no x or variable present. So in this case my constant would be 7. So I write my 7. Alright, once I have all of the terms accounted for and present in one of the columns, so we have 1, 2, 3, 4, 5, 6 terms total. And if you notice, I have 1, 2, 3, 4, 5, 6 terms accounted for. Okay, so we just want to make sure everything is accounted for. Alright, so now once we have everything accounted for, we can go about the business of adding those terms that are considered like. So we start with our x to the third. Because we only have a 4, we can bring that down, and that's 4 x to the third. Now with our x squares, we have a negative 6 and a positive 5. So when we combine a negative 6 with a positive 5, negative 6 plus 5 is a negative 1, and that's our x squared. So negative 1x squared. You don't write the 1. Remember, we do not write the 1's in front. You just write the negative x squared, and the 1 is understood to be there. There's understood to be a 1 right here. Okay? Now we go to our x's. We have a positive 2, minus 2. So actually 2 minus 2 cancels. So you don't have any x's for an answer. And then lastly you have your constants, which is 7. And there's nothing to combine it with, so you just bring it down. It's a positive 7. So you write your plus sign. So your answer would be 4x to the third minus x squared plus 7. Alright? Let's look at another one. Let's say we have, let's see here, say we have 7x squared minus 3x plus 4, alright, plus negative 2 x squared minus 8x plus 11. Alright, so a trinomial plus another trinomial. Again, we always want to just be sure to double check to make sure that none of the terms inside of the parentheses can be applied to any other operation. That can't be combined or anything like that. Same with this parenthesis over here, can't be combined. Okay, so now, excuse me, put that minus sign back there. Alright, so now we want to combine like terms from this parenthesis with like terms from that parenthesis, and I'll look them all over. The highest degree is square, so that's what I'll start with, x squares. And if I'm going to count down, descending order, standard form, or decreasing order, says if I'm going to start with the highest degree, which would be squared in this case, because that's the highest exponent you see. Alright, and then counting down would be x to the 1, which is just my x's, and x to the 0, which is just my constants. So x squares. Notice here I have a 7x squared, so I write my 7. And over here I have a negative 2x squared, so I write my minus 2. For my x's, I have a negative 3, so I write that. And over here a negative 8. And for my constants, x to the 0, I have a positive 4 and a positive 11. Okay, so everything's accounted for. I have 1, 2, 3, 4, 5, 6 terms in my problem, 6 terms total, and I have 1, 2, 3, 4, 5, 6 terms accounted for in my column alignment to do the combination of like terms. So for my x squares, I have 7 minus 2, which is a positive 5, x squared. For For my x is a negative 3 minus 8, which is a negative 11. And that's my x's, x to the first, which is just x. And for my x to the 0, which is nothing but a constant, 4 and a positive 11. It's like saying 4 plus 11, which would be a positive 15. So when combined, the answer would be 5x squared minus 11x plus 15. Alright, let's look at another one. Let's say we have 5x minus 15 plus 2x squared minus x plus 7 plus 5x to the third minus x. Alright, so now this time we're adding 3 polynomials. So we have 1, 2, 3 polynomials being added in this case. Alright, so once again you're going to look them all over, but first you're going to check inside the parentheses, see that there aren't any like terms inside of the parentheses to be combined, and there aren't. Okay, so now you're going to look to find the highest degree out of all of the parentheses that are present. So in this case, highest degree is third. Okay, when I look over all of these, the highest degree is third. So that'll be my first column, x to the third. And then again, we're going to do a countdown. Decreasing, descending order says we're going to do a countdown. So after x to the third is x to the second, then x to the first, then x to the 0. So all we're going to do is align all the terms up under the proper column. X to the third, the only x to the third I have is this 5x to the third, so I write my 5. Now I look for x squares, look them all over. The only x square I have is this 2x squared, so I write it down. For my x's, I see I have a 5. This minus x is the same as saying minus 1, because it's like saying minus 1x, so minus 1. And once again over here we have a minus x, so that would again be the same as saying minus 1. For our constant terms, we look and we see this minus 15. That's an x to the 0, which is a constant term, so minus 15. And we have this plus 7, which is a constant term. Alright, so let's double check. 1, 2, 3, 4, 5, 6, 7. Alright, so that's 7 terms present in the initial problem. Now let's see if we've accounted for all 7. 1, 2, 3, 4, 5, 6, 7. Okay, so we've accounted for everything. So now we can combine based on the column that they're lined in. Alright, no x to the thirds other than this 5, so I can bring it down. And that's simply 5x to the third. No x squares other than this 2, so I can just bring it down, and it's a positive 2, so positive 2x squared. Now my x's, I say 5 minus 1. 5 minus 1 is 4, and then 4 minus 1 is 3, and it's a positive 3, so plus 3x. And then for my constants, my x to the zeros, I have a negative 15 plus 7, which is a minus 8 or a negative 8. And there you have your final answer. Alright, so that sums up addition of polynomials. So now let's look at subtraction. So this time we're going to focus on subtraction. Alright, so talking about polynomial operations, but now we're going to focus on subtraction. So let's say we have 5x minus 3 minus 2x minus 11. Okay, so again, we're checking inside of the parentheses to see if we can combine the terms inside, and they're not alike, so we can't. And look over here saying they're not like, so we cannot combine what's inside. So once again, we're going to look to combine like terms from one set of parentheses with the other set of parentheses. But this time we see the operation is subtraction. Okay, now because we've learned addition, and just generally speaking, most people seem to have developed a more a greater comfort with addition than subtraction. I typically encourage people to just change subtraction problems to addition problems. So since this is minus, what we're going to do is change this minus. Alright, change this minus to a plus sign. Alright, because we like addition, we're comfortable with addition. Alright, now we're able to do this as long as we change all of the signs of the polynomial that follows the minus sign. Alright, so here's the minus sign. So this would be considered the polynomial that follows the minus sign. So as long as we change all of the signs in here, then we can turn this subtraction into addition. So right now it's a positive 2x, so we're going to change this positive 2x into a negative 2x. Right now it's minus 11, so we're going to change this minus 11 to plus 11. Alright, so that's what I mean by changing the signs. What was initially a positive 2x is now a negative. What was initially a negative 11 is now positive. Now because we've changed all of the signs in the polynomial behind the minus sign, we can now change minus to addition. Okay, so we look and we see x to the first is our greatest degree, our highest degree, and when we count down, the only thing behind it is x to the 0. So we have a 5x and now a negative 2x, and for our constants, our x to the zeros, we have a negative 3, and now it's a positive 11. So when we combine, 5 minus 2 is 3x, negative 3 plus 11 is a positive 8. So that would be your answer. So all we're really doing is basically turning subtraction to addition, and we're able to do that by changing the signs of all the terms in the polynomial that follows the minus sign. Okay, so let's look at another problem. Let's try 5x squared minus 2x plus 1 minus negative 6 x squared minus 8x minus, well, let's make it a plus 1. How about that? Alright, so now we have another problem, a new problem. Okay, it's a different problem. Okay, try to keep it separated here. Alright, so now we have this new problem, basically looking at subtracting trinomials here. Alright, so both of them are trinomials, both of our polynomials are trinomials. And when we look inside of the parentheses, none of the terms are like, so we can't combine any like terms inside of the parentheses. Okay, so once again, we're looking to combine like terms from one set of parentheses with like terms of the other set of parentheses. And we do that once again by changing subtraction to addition, And if we're going to change subtraction to addition, we have to change all the signs of the polynomial that follows the minus sign. So this negative 6 now becomes positive 6. This negative 8 now becomes positive 8. And this positive 1 now becomes negative 1. So once I change the signs, then I'm free to align my terms under the proper columns. So highest degree is square, so x squared, then counting down, descending order, decreasing order, which is standard form. X squared, x to the first, which is just x, and x to the 0, which is constant. Okay, so my x squared, I have a 5x squared, and now I have a plus 6x squared, so positive 6. Alright, under my x's I have a negative 2, and now it's a plus 8. Was a negative 8, now it's a plus 8, or positive 8, however you want to look at it. Okay, for my x to the zeros, or my constants, I have a 1, and now a minus 1. So everything's accounted for. 6 terms total in the problem. 6 terms lined out. So now 6 and 5 is 11. That's x squared. Negative 2 and 8 is a positive 6, and that's my x. 1 minus 1 is 0, so I don't have any constants. So there's my answer. Alright, let's try one last one here. Let's go with we want to try negative negative 3x squared plus 7x minus 2 minus 5x to the third plus x minus 7 plus 4x squared plus 8 minus 3x to the third. Alright, so that's a 3x to the third. There we go. Clean that up a little bit. Alright, so there it is. Now we have 3 different polynomials that we're looking to combine. Alright, none of the terms inside are considered like, but the other thing we have to notice is now we're talking about subtracting the first 2 and adding on this last one. Okay, so when we go to work this one out, again we identify our highest degree. In this case it's to the third. Our highest exponent is 3, so our highest degree is 3, since it's a single variable. So we're going to start with x to the third. Decreasing order or descending order says count down, so putting them in standard form calls for us to do this. Alright, now again we've talked about changing subtraction to addition, so here's my subtraction. So change it to addition, change that from minus to plus. Now this is a positive 5x to the third, so I have to change it to a negative 5x to the third. This is a positive x, so I change it to a negative x. This is a negative 7, so I change it to a positive 7. Now notice I am not going to change any of these signs because these signs do not follow a minus sign. The terms in this parenthesis follows a plus sign, so there's no need to change these. The only time we change the signs is when the terms are in a parenthesis that follows a minus sign. Alright, so now we're all set to list out our terms. So our x to the thirds, we have a negative 5 here and a negative 3. Alright, our x squares there's a negative 3 right here, and a positive 4. Okay, our x's, we have a 7, a negative 1 right here, that's a negative 1x, so a negative 1. And then our constants, okay, for our constants, we have a negative 2. Oops, let me double check, hold on. Alright, we have that. For x to the third, we have a negative 5 and a negative 3. Okay, I want to double check this. For x squared, negative 3 and a positive 4. For my x's, I have a 7, a negative 1. Alright, and now, okay, for my constants, I have that negative 2, I have this positive 7, and I have this positive 8. Alright, just making sure I didn't get myself all mixed up there. So these are 3 trinomials, so that means I have 3 polynomials with 3 terms inside of each, so a total of 9 terms. So let's look. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so everything is accounted for, so we're ready to combine. Negative 5, negative 3, negative 8, and that's x to the third. Negative 3 plus 4 is a positive 1, and that's x squared. Remember, the 1 is understood. We do not write it. It's understood to be there, the positive 1. 7 minus 1 is a positive 6, and that's the x, or x to the first, which is just x. Negative 2 plus 7 is a positive 5. Negative 2 plus 7 is 5. 5 and 8 is 13. Positive 13. There's our answer. Everything's been accounted for. Therefore, we are finished. So, hopefully now you're a little more comfortable with adding and subtracting polynomials. Remember, for subtraction, all you need to do is change subtraction to addition, and to do that you need to change the signs of the terms inside of the parentheses inside of the polynomial that follows the minus sign. Alright, and with that we will conclude this session.